Let us evaluate the limit of x tan theta minus theta tan x by x minus theta as x approaches theta. You see that in most of the cases, we got the formula limit h tends to 0 or limit theta tends to 0. We don't got such an expression, limit x tends to theta. So what we do is we simply let x minus theta equal to h, or x equal to theta plus h. Then when x approaches theta, comma, h approaches 0. So this limit must be equal to limit h tends to 0. Instead of x, we can write theta plus h. Instead of x, we can write theta plus h. Instead of x, we can write theta plus h. Rest of the expression we can copy as it is. So instead of x, we wrote theta plus h. Tan theta we copy as it is. Minus theta we copy as it is. Tan we copy as it is. So tan of theta plus h. Since x minus theta equal to h, we can write denominator simply equal to h. Now can we compute the limit? Limit h tends to 0, that's fine, but still we are not getting some formula here. However, we can write theta plus h tan theta as theta times tan theta plus h times tan theta minus theta tan theta plus h we copy as it is. So we copy as it is. Now you see that h and h can be cancelled, but only for this expression h tan theta by h. So let's write it separately, h tan theta by h. Rest of the expression we can copy as it is, h as it is. Theta tan theta we copy as it is, minus theta tan theta plus h we copy as it is. Limit h tends to 0, so h is tending to 0, or we are taking h as close to 0 as possible. You see that from this expression we can take theta common and we can expand tan theta plus h. Let's do it. Once again, we can take theta common and we can expand tan theta plus h and write it as tan a plus b is tan a. So tan theta plus tan h, tan a plus tan b, divided by 1 minus tan a into tan b, tan theta times tan h. We took theta common. Tan theta we can write as it is. H and h can be cancelled, so we will be left out simply tan theta. Now, can we simplify this expression? Of course. So 1 times tan theta is tan theta minus tan times tan is tan square. So tan square theta tan h minus tan theta minus tan h. Okay, this has an advantage that we can cancel tan theta. Tan theta minus tan theta is simply 0. However, the denominator, in denominator we'll get 1 minus tan theta tan h whole thing multiplied by h plus tan theta we copy as it is. Now we see that we can take tan h common, so we take tan h common and route it outside of the fraction. Let's write h also outside the fraction. We will be left out with minus tan square theta minus 1, and then 1 minus tan theta times tan h. You see that limit h tends to 0, tan h by h is simply 1. Can we calculate this limit? Of course, yes. As h tends to 0, theta do not change, so we write as it is. As h tends to 0, tan h by h tends to 1. How about this one? we write as it is, minus 1 minus tan square theta divided by, as h tends to 0, tan h also tends to 0. So this whole expression will simply just tend to 1 plus tan theta we write as it is. Can we simplify this expression? Of course, yes. If I take minus common, then I am left out with 1 plus tan square theta, that is sec² θ plus tan theta. That's the final answer.